What's up everyone, Patrick here, welcome back, and moving on to another word problem. So suppose the amount at any given time of a decaying substance that starts at an initial amount of I, which is in grams, after t years, is given by this formula here. So A of t, the amount after t years, is the initial amount times e to the power of negative 0.028 times t. And given that formula, we have these two questions here. So number one, to what amount will 1,000 grams of the substance decay to after 15 years? And then number two, how many years will it take 900 grams to decay to 30% of its initial mass? So starting with number one, we have this formula here, and in number one, notice we're given the initial amount that it's starting at 1,000 grams, so that's what we would plug in for I, and then we would plug in 15 for t to figure out the amount after 15 years. So basically we're looking in number one for A of 15. We're starting at 1,000 grams, e to the power of negative 0.028 times 15, like that. And when you do this entire calculation, what you would end up getting approximately, if we round to the nearest gram, is 657 grams. So it starts at 1,000, and then after 15 years, it decays to 657 grams. So that's the answer to number one. And then number two, it's a little bit more complex. So how many years will it take 900 grams to decay to 30% of its initial mass? So notice how it's starting at 900 grams, and then it's decaying to 30% of that initial amount. So 30% of 900 would give us 270, right? 0.3 times 900 would be 270. So in this case, we're given the initial amount, we're given the final amount, and then we have to solve for t. And it's going to take a little bit more algebra. Another way this could have been worded is if it decayed 70% of its initial mass, right? If 70% of its initial mass decayed, then 30% would be left. So that's another way it could have been worded. Another thing I want to mention, and I'll show you at the end of the algebra, is this 900 grams here. It's actually irrelevant. We're going to use it initially to show you the algebra, but that actually didn't have to be given. It could have just said how many years will it take for the substance to decay to 30% of its initial mass, because you're going to see because of this 30%, it doesn't actually matter where it starts. The final answer is going to be the same. But initially I'm going to use these two values. So we'll have 900 equals, the final amount is 270, the initial amount is 900. And then we're going to be solving for that t. So the way we would do that is, first we have to divide by 900 to get rid of this. And then 270 divided by 900, that would give us 0.3, or 3 over 10. And that's going to be that's going to equal e to the power of negative 0.028 t. And actually, this is a good time to explain. No matter what you use here, you're always going to end up with this equation, right? Because let's say that it started at 1,000 grams. Well, 30% of 1,000 is 300. So you would put 300 here, 1,000 here, and then when you divide by 1,000, you'd end up with this 3 over 10, right? And just to generalize it, if it starts at I, an initial amount of I, then 30% of that is going to be 0.3i. So you would end up getting 0.3i equals I, the initial amount, e to the power negative 0.028 t. And so when you divide by I, no matter what it is, notice that it's going to just cancel out, and you're going to be left with that 0.3. Right? That's why I was saying the 900 grams is actually irrelevant, even though we can use it in the specific question. But again, if this was maybe a little bit more general, how many years will it take to decay to 30% of its initial mass? You can generalize it like this, and then the i's would just cancel out. Right? So whichever way you do it, this is the equation here we have to solve. So I'm actually going to keep it in decimals just because we have decimals here. So I'll keep the left side in decimals. So we have to solve for this t over here. So how are we going to do that? Well, we need to bring this exponent down. So what we would do is we would ln both sides, right? Because we have a base e over here. And then if we ln this using exponent rules, well, we can now bring the exponent down. So we'd have ln of 0.3 equals negative 0.028 t, and then we'll have ln of e, like that. And then ln of e, that is just equal to 1, so we actually just end up having this on that right side, and then to get that t, we would divide both sides by negative 0.028. Like that. And so the t, the number of years, that's what we're solving for, number 2, would be ln of 0.3 over negative 0.028. And when you do that calculation, you'd get approximately 43 years. Right, so it would take 43 years for this substance, if it starts at an initial value, to decay to 30% of that initial value. Or more specifically in this question, for 900 grams to decay to 270 grams, 30% of that. And then you could check this. So you could plug in 900 here, then you could plug in 43 over here, and then you'll notice that that final amount you're going to get is going to be something very close to 270.